Welcome to lesson 1 of this section. Going forward, we'll be using a text editor, whether it's Atom, Sublime, whatever you choose to work with. The purpose of this section is to build a program that can identify lane lines in a picture or a video. When you and I drive a car, we can see where the lane lines are using our eyes. A car doesn't have any eyes, and that's where computer vision comes in, which, through complex algorithms, helps the computer see the world as we do. In our case, we'll be using it to see the road and identify lane lines in a series of camera images. This lesson in particular will be quite simple, as all we're going to do is set up the initial stages of our project and display an image, onto which we'll be identifying lane lines. You'll start by opening up your terminal or command prompt and navigate to the desktop directory with the command cd desktop. Change directory desktop. Inside of desktop, we'll make a new folder with the command mkdir make directory finding lanes. This folder you just made inside of desktop, you're going to open up with Atom by going to File, Open, Desktop, Finding Lanes. Inside of Finding Lanes, make a new Python file called lanes.py. Inside of the lanes file, we're going to start by writing a program that can identify lanes in a JPEG image. I posted the image on my GitHub. To access it, make sure to go to the following link. And so once you get to this GitHub page, click on testimage.jpg. And what we're going to do is actually download the image, or better yet, just save the image, and make sure to save it as a JPEG image. It doesn't matter where you save it, and make sure this says test image such that there are no extra 1s or 2s in there, so that your naming remains consistent with what I have in the videos. Alright, save your image. Once you download it, wherever you have it downloaded, make sure to drag it into your project folder like so. And now to display the image, we're going to use OpenCV, an open source computer vision library. So inside of your terminal, we're going to write the command pip install. Will make use of the package manager pip to install opencv-contrib-python. Once you're finished installing it, back to Visual Studio, we're going to import the library CV2. And from this library, for now, we will access two functions, imread and imshow. To load our image, we'll first make use of the imread function by setting image is equal to cv2.imread, and in this argument is where you will specify the image, the file name, as a string. Ours is testimage.jpg. And what this function will do is read the image from our file and return it as a multi-dimensional NumPy array containing the relative intensities of each pixel in the image. We now have our image data in a NumPy array. The next step is to actually render it with the imshow function. So we'll write cv2.imshow. This takes in two arguments. The first one is the name of the window that we're going to open up. We'll just call it result. And the second argument is the image that we want to show itself. If I run the code now to my terminal, navigate to my project folder by writing cd, our project is named Finding Lanes, and run the Python file, python-lanes.py, notice that nothing is going to happen. That's because this function should be followed by the waitKey function, cv2.waitKey, and what this function does is it displays the image for a specified amount of milliseconds. We'll set a time of 0. What this will do is it will display our window, our result window, infinitely until we press anything in our keyboard. If we rerun the code, Python lanes, the image is displayed, and notice our window name results. We'll keep this lesson short and stop here. You learn how to load and display images using the OpenCV library. In the next lesson, we'll start discussing canny edge detection, a technique that we'll use to write a program that can detect edges in an image, and thereby single out the lane lines.